Hello everyone. Good morning, good afternoon, good evening to you. Welcome to today's exclusive webinar by HCL and Siemens on enabling integrated product engineering. I am Pushkar Patil and I will be the moderator for today's webinar. Before we begin, let us meet the panel of leading industry experts joining us today. We are very lucky to have with us Luca Benporat, Vice President, PLM and Digital Transformation at HCL, Dr. Amber Gadkari, Head Systems and Software Lifecycle Management COE at HCL. We have Mark Sampson, Systems Engineering Evangelist at Siemens. And we have Hemant More, Group Project Manager at HCL. So with this, I would like to hand it over to Luca. Luca, over to you.
Thank you, Pushkar. Thank you very much. Hello, everyone, on behalf of the whole team. Good morning, good afternoon, good evening. I would like to kickstart it with this presentation to give you a little bit of a background that will be used then by my colleagues to deep dive into the main topic, which is MBSC, into the product lifecycle management. So let me start to give you some first information for those who is less familiar with HCL. We are almost 160,000 people company and recently achieved the $10 billion revenue, which it's a great achievement for our company. But most of all, behind that 10 billion, there are all the HCL employees working in 50 countries, belonging to more than 150 nationalities, building relationship and building trust with all our customers at a daily basis. Actually, most of our engagements are 10 or 15 or 20 plus years duration, which really shows that we are serving our customers on a daily basis, but also with a long-term relationship. We're also very lucky to be awarded by Forbes as the world's best employers, as well as in various countries, we are ranked as the main top employer in various countries in the US, in Asia Pacific, and in Europe. So if we move to the next slide, this slide, of course, may not be a surprise for any of you who have been managing digital thread and digital transformation in your company or in your department. Actually, HCL has been working to enable and support their customers to go this journey for many, many years. And of course, without entering into much details, I'm pretty sure you're familiar. Let me just tell you that in the way we work with our customers is to support them on two main axes of collaboration. The first one, of course, is what this picture is all about, is to make sure that data coming from product and product design are shared across the whole company, regardless if it is in engineering or in manufacturing or in supply chain and supplier collaboration, or in sales and after sales, or even in finance for product costing. This is really the roadmap that we work with our customers. Some customers have needs which are different from others, but all in all, this is really the big picture for which a lot of our customer of ours are aiming to. When then we deep dive into the engineering, there is one additional challenge: to have a full convergence between three main components when we think about a product, which are the mechanical engineering, the software engineering, and electric design. All these three management has been typically going into kind of silos, and our aim is really to start the convergence because, of course, one product has different viewpoint that you can see. And what you will see during this webinar will really be how in HCL we concretely help our customers moving into that consolidation and harmonization with the right mix of competences, software, IP solutions, and best practices that are helping our customers to go for this convergence of software, electronics, and mechanical. If we move to the next slide. So This was really the high-level picture. And now I would like to hand over to Mark, who will start to deep dive into the Siemens view and how Siemens is approaching this topic. Over to you, Mark.
Well, thanks, Luca. Good morning, good afternoon, good evening, everyone. It's good to be here with you today. What I'm going to talk to you guys about today is streamlining this product innovation part of the problem. Now, according to Interx Mobility Analytics, depending on where you live, you'll spend about 200 hours per year stuck in traffic jams. So you have your own traffic jam in your own product development process. In fact, you're spending as much as half your product development on what we call systems integration cycles. Now, we're out to solve that by integrating product architecture and requirements with the product lifecycle. And what this does is it enables continuous integration, and that dramatically streamlines your product development process. If you go on to the next slide. Now, most organizations, of course, recognize the importance of product architecture and requirements, but they are typically managed outside the product lifecycle in documents or standalone requirement and standalone modeling tools. Now, since those requirements and system models are outside the product lifecycle, they don't have the power to prevent problems without a lot of manual integration effort. So, for example, some of you may have received a recall notice from your car manufacturer. The automotive industry had some 54 million of these recalls in the US last year. The National Highway Traffic Safety Administration in the United States says that each recall costs about $100 per recall per vehicle. So that's 5.4 billion in direct costs that was spent last year on the problems in 2020. So as you read the causes, you'll note that most of these are compliance and multi-domain combination kinds of problems. Going on to the next slide. So what we're after doing here is this is a symptom of organizations and disciplines and complex system interactions that are all attempting to communicate in disconnected ways. So today, without this digital thread in your organization, and the discipline boundaries and organizational boundaries create these barriers to communications that results in communication engineering problems across those boundaries. For example, a requirement change on one side of the barrier isn't communicated to the other side, and so we have a problem. So the later we discover those lost communications, then the more expensive it gets. But of course, you already know all this. In fact, you set aside half your program schedules in complex systems to deal with these kinds of integration problems. On the next slide, please. So what we're after doing here is integrating the system modeling or system architecture and the requirements with the product lifecycle so it flows throughout the entire product development process. And this enables you to drive the downstream development with these architecture requirements flowing to everyone, everywhere. And what this does, of course, is improves your communication to eliminate these integration problems that are currently consuming much of your program schedules. So you go on to the next slide here. So what this does is this creates an, if you will, an architectural GPS system by integrating the system models and the requirements with the product lifecycle. So the models become these blueprints, are actively guiding you on your product development journey, including your suppliers, by the way. So you already know how this works because you use this kind of technology every day in your journeys with your GPS on your mobile phones and your vehicles. And what we're after doing here is by integrating the system modeling and the requirements with the product lifecycle enables you to avoid your current late cycle architectural problems by continuously integrating or continuously guiding you with this dynamic system modeling that is included with the product lifecycle. So as we put it, starting integrated and staying integrated. So if you go on to the next slide, please. So what we're going to be talking about today is we're doing this by integrating the system models on this left-hand side of the diagram you see here, and integrating them with the product lifecycle here in the center, and then carrying that information through PLM into the downstream development domains. Now, once it's integrated, then we can now participate they can now participate in the standard PLM services, such as configuration or change, workflow, all the kinds of different things that you would expect of a PLM environment. Also, once it's there, it establishes these relationships and interdependencies that are needed to help you understand the consequences of changing requirements and changing system designs across the product lifecycle. Now, the interesting thing about systems engineering is even making no decision is a decision because everyone's moving on with or without you. So now when we're integrated, that means I can also see where this goes, and I can see where it goes now, so I can see what effect it has on my schedules, in the downstream domains, electrical, mechanical, software, and manufacturing, cost, reliability, and the list goes on. So what this does is it captures the relationships and dependencies needed to understand these interactions, and then the impacts of how that change will carry throughout the entire product's development process. So we're going to spend some time now in this webinar talking about integrating this left side of the product development process in the system modeling area with tools like Cameo and Rhapsody with the product lifecycle. So with that, we'll carry on.
Hello, this is Ambar Gadkari, and I'll walk you through some of the approaches that we have been developing on integrating MBSC with the rest of the product lifecycle. So as mentioned by Luca and Mark, modern products as well as the product lifecycle or product development lifecycle are getting more and more multidisciplinary in nature. So by multidisciplinary, we mean it's a good integration or very tight integration of software with the electronics and the electrical and the mechanical parts that are inherently there in the modern products, including cars and aeroplanes and many other products. As you can see in this picture, there are not just one single V cycle in the engineering development activities, but there are multiple Vs that are happening or that are being worked on in parallel. So the approach of MBSC or model-based systems engineering, which is applied at the left-hand side of the V, at the top left-hand side corner of the V, that is the approach that is being taken or adopted by most of the organizations in handling the complexities that are introduced by bringing in multidisciplinary nature in the engineering processes. So it starts all with requirements, gets down into the functional, logical breakdown of the requirements, and then continues to the actual physical design or detailed design and the physical implementation of the systems. And then the traceability also continues in the various testing activities that is on the right-hand side of the V, as you can see. The need is also arising to even create the traceability not only just in the engineering silo, but also going beyond engineering into manufacturing and even aftermarket. And that is all met by bringing in the model-based nature in the engineering and development processes right in the beginning at the requirements level. Going to the next slide. So let's look at how this is achieved. So as you might be aware, many of the engineering processes, may it be mechanical or electrical or electronics, most of them are as a life cycle or as the workflows are controlled or are handled by tools which are called product lifecycle management tools or the PLM tools, as well as the software, which is a newer entity in this entire product development. Those are being handled by tools which are called as application lifecycle management or ALM tools. So PLM and ALM together, they actually cover most of the activities that are related to the design, development, and testing of these products. However, bringing in the model-based approach of the requirement at the requirements level requires bringing in MBSC at an early stage before even the design, detailed design, and these activities start. And that's where some of the newer tools like Cameo Systems Modeler, Rhapsody, these are being looked at, and the systems modeling languages like SysML are being adopted very rapidly. And the need that is being seen by the industry is how do we have seamless flows or seamless workflows created so that MBSC tools or MBSC processes get adopted in the mainstream product development lifecycle seamlessly. And that is what we will talk about in next few minutes of this webinar. We can go to the next slide, please. At HCL, we have this dedicated R&D unit, which we call as Systems and Software Lifecycle Management COE, or in short, SysLM COE, which focuses on developing solutions for integrations across ALM, PLM, and MBSE tools. Through our 360-degree partnerships with various tool vendors, we have been able to develop various solutions. And one of that is what you see on the screen is MODEX. MODEX is a short for Model Exchange Solution. MODEX is actually a data exchange solution for system modeling activities that are being carried out as part of the MBSE block that you see there. MODEX comprises not only the connectors, but it also has components which are like the consulting and the services which are associated with that. And it uses pre-built tool-to-tool connectors for connecting MBSE tools with the various product lifecycle tools, such as requirements engineering or requirements management tools and the product development and the detailed design tools actually. This is required in realizing various different use cases, such as you may have need for automatically importing requirements from the requirements management tools, such as ALM tools or PLM tools, into the SysML format. So that is one of the kind of use case that is handled by MODEX. The other use cases could be where you need to have a proper model management or the requirements management activities that have to be carried out using the standard ALM, PLM tools. There are also situations where we have come across where you need to export the entire model structure. So you might be doing high-level modeling using SysML models, and you might build some kind of a system structure there. And it would be very helpful if this system structure is exported into the product lifecycle management tools in form of product structure, from where it can actually have the detailed BOM management activities that can be carried out further. So these are the kind of use cases. Apart from this, there are also downstream activities where MODEX builds the connectors or helps in connecting so that you can carry out co-simulation activities or kind of correlate the analysis that is being done at a high level abstraction in the system modeling language with the lower level detailed activities that are carried out using the MATLAB Simulink or Modelica or other detailed design tools. This overall creates a seamless end-to-end workflow from requirements to production and even beyond. In the next section, you'll actually see how we have built one of the connector with our collaboration with Siemens. This connector is called Cameo Team Center Connector. And we'll show you the demo as well as talk about some of the details and how you can yourself try it out with free trial versions. So over to you, Hemant. Please, you can take over. Thank you.
Yeah, thanks, Amber. So, as Amber talked about integration of MBSE and PLM, as a part of HCL offering of MODEX, we develop connector to integrate Cameo System Modeler with Team Center. This solution is developed in partnership with Dassault System and Siemens. This connector delivers capability to integrate system modeling data and artifacts from Cameo with Team Center, and ensuring the downstream connectivity of data and the bidirectional traceability across these tools. In next slide, I will talk about some of the capabilities and feature of this connector and also show you small demonstration. Can you move to next slide, please? Yeah. So this integration, which is already available in the market, supports some of the major use cases. I will explain them briefly here, and then we can see them in the demonstration. One of the key use case is model management. This is about sharing of system model with Team Center and save in Team Center repository. Perform some of the operations, change management operations like check-in, check-out, revise, and other similar operations. This is not only the file, but we can store diagram as an images so that user can get the system information in downstream workflows. The next use case is a requirement integration, which is about exporting them to the team center and use in PLM domain. At the same time, user can drag and drop some of the requirements from team center to appropriate location on project model in Cameo. During these operations, CSML model is created as per the default mapping. Most of the primary types are supported here using this default mapping. The next key use case is a bidirectional data synchronization between Cameo and Team Center, keeping the traceability throughout the life cycle of the product. If you have any questions or need to know more about the features or capability, please raise the same in the chat window. We can take them in a question answer session. Now, let's talk about the supporting capabilities of this connector. So one of the useful capabilities is hosted active workspace within this Cameo, so that user can browse Team Center and model without actually launching it. This allows user to open model in Cameo and active workspace, review that data, and also drag some of the necessary requirement which required in the system model from Team Center to Cameo model. And then these requirements becomes a part of system model for further processing of the system model, and then again synchronize it with the Team Center model. The next use case is out-of-the-box mapping between CSML and Team Center modeling items. Data synchronization and creation of the model structure will use this mapping, which is default available, and if required, user can customize some of the types to synchronize the other elements from the Team Center and the Cameo. Model compare and merge also allows user to compare base model with source model and check the differences and take the appropriate changes in the system model. In the next slide, we will demonstrate you the connector from end user perspective. We will see how the system architect, requirement manager, and system engineers work in a collaborative manner to perform end-to-end workflow using some of the features and capability of this connector. Please play the demonstration.
HCL's Cameo Team Center connector is an integration solution developed to bridge the gap between MBSE and products engineering. Let's see how the systems engineering team gets benefited using HCL solution. Here, Lynn is the requirements manager. She is responsible for requirements gathering and elicitation. Josh is the system architect. His role is to understand the requirements and formulate the system architecture using MBSE tool. His team of system engineers, David and Sarah, works on further granularizing the MBSE specifications using suitable methodology. Josh has chosen Cameo Systems Modeler to develop the adaptive cruise control system using SysML. The top-down method of system modeling begins with mission requirements, high-level functional decomposition, and logical modeling, ensuring the traceability with appropriate relationship. For example, satisfy, allocation, refine. This model is shared with David by exporting it to Team Center. On successful export, the ACC model is transported to Team Center objects, as per predefined mapping rules. The corresponding Team Center ID and revision properties are updated on Cameo model elements for Team Center model management. The feature of visualizing this model in the embedded active workspace will help in quick review of transported model elements to Team Center. David imports this model and performs further modifications to add more details. He first revises this model from Cameo UI to incorporate modifications. By using a drag and drop feature, David brings the newly added requirements for obstruction detection from Team Center to Cameo. David creates new camera block to satisfy the new requirement of obstruction detection. Once his modifications are complete, he quickly publishes this back to Team Center using selective synchronization option. He checks in this model to make it available for Sarah to let her implement her design details. Sarah verifies the changes by David in Active Workspace web client. However, Sarah also wants to merge her offline work. She used the sync and merge feature to push her modifications in SysML model. HCL's Cameo Team Center connector solution also provides nice-to-have features to execute directly from Cameo UI, such as compare revision and switching to other revisions. These features improvise the user experience by eliminating the switching between the applications. The connector solution will truly help the industry to take the advantages of MBSE by connecting it with PLM and subsequent downstream engineering designing silos.
Yeah, can you go to next slide? Yeah, so as we have seen, this connector is very useful in the integrated product development environment. This connector enables team to collaborate and understand the impact of their design early in the product lifecycle. It minimizes the unnecessary rework also. User can reuse the product requirements, system model, and expedite the complex product design decision and reduce the overall timeline to go to the market for the product. Next slide, please. Yeah. So as we have seen that the current version has some of the very good features and capabilities to perform major operations and workflows. However, we still have a few features in backlog, and you will see them in upcoming releases. Some of the good features are support of parameters to perform system analysis, support of project dependencies, support of Teamwork Cloud to enhance the data exchange capability, and of course, our plan to add a few more features based on your feedback that we receive, and as well as from the customers who have bought these few seats and those who are using trial versions. In the next section, I will ask Mark to summarize the importance of integration. Over to Mark. Thank you.
Thank you. So to kind of summarize here for everyone, we want to point out to you, you don't have a engineering problem, you have a communication problem that consumes half your program schedules because things are not being communicated across domains, across organizations. So today's products, of course, you know, are built everywhere. Using unscalable document-oriented or disconnected process just can't keep up. Using discipline-specific models that provide limited views won't catch all these cross-domain problems that you're experiencing. And of course, this needs to be supported by a cross-domain language. That's why SysML and other system modeling languages are so important. So the result is that you're going to spend half your time on your program schedules on system and supplier integration and endless meetings, hoping to communicate across domains. Now, we're proposing a different approach here. Is to start integrated at the earliest stages of your product development process, and then stay integrated by integrating a product architecture with its requirements, parameters, more delivered through a PLM system that everyone, including your suppliers, can see and understand. What this does is this enables everyone to stay integrated throughout the entire product development process and the delivery so that you don't have experiences that are making headlines today.
Please do visit our the contact details that are given. You can write to us for more details as well as the trial version downloads. Thank you again. Thank you very much.
Thank you all. Thanks for.
Take care, everyone.